Hi, my name is Alexander Komagin. I'm a founder and CEO of Adiom, where our mission is to streamline enterprise data migration and replication tasks for engineers and DevOps. In this video, we will take a look at how to use dsync to perform an online migration from Amazon DynamoDB to Azure Cosmos DB NoSQL database. Dsync is an open source database migration tool that we at Adiom develop and support. It allows to streamline an otherwise complex database migration process from Dynamo to Cosmos DB. You can now run it as a single command. Dsync supports all the common functionality required for live production migrations without needing the user to perform any complex infrastructure setup, write custom scripts, or code. On a high level, a typical live migration process consists of the following 4 steps. First, we need to do the initial data copy from the source to the destination. Then, we need to catch up and replicate all the changes that happened during step 1 from the source to the destination. And then we need to keep replicating the new changes. When the replication lag between the destination and the source is small enough, the user can switch the reads to the destination and stop the writes to let the both source and the destination get in sync. When they are fully in sync, the user can run a data integrity check and cut over to Cosmos DB. Here is our source DynamoDB table. It has just over 2 million records. An important note, for the change data capture to work, we have a DynamoDB stream enabled and configured with the view type set to new image. We will provision a new Cosmos DB NoSQL database and container as our destination. We will disable indexes to make sure the data ingestion goes faster, and we will use the ID partition key that dsync populates with the original DynamoDB partition key. Now that it's creating, here is our pretty regular VM where we will be running dsync. To run dsync, we need to start a background process to connect to Cosmos DB NoSQL, which we already done here. And we need to connect to AWS using the AWS CLI. Then we just need to specify the mapping from the DynamoDB table name to the database and container in Cosmos DB. DynamoDB as the source, and the Cosmos DB NoSQL connector as the destination. When dsync starts, it creates a read plan by splitting the source table into tasks, and then it transitions to the initial data copy stage, where it executes those tasks in parallel. After the initial data copy is completed, which takes about 8 minutes here, dsync automatically transitions to the change data capture mode. To try and test change data capture, we can insert a new record into the source table and see that it propagates to the destination in real time. Here it is on the source. And here it is on the destination. We can also see in dsync's output that it registered this one change event on the source. You can get more information about Adiom and dsync on our website, in our documentation, or our GitHub repo. Feel free to contact us using the form on the website.